Hello everyone, this is Jaspal, your host, and today we are here for our BitCast episode number 5. And along with me, I have a very dear friend, the co-founder of DecBC and Blockchain Zoo, Mr. Roberto. Hi Rob, how are you?
Good. Hello Jaspal, thank you for having me here also today. And I am in Europe now, in the Dolomites, where internet is not good, as we discovered, but hopefully we're going to be lucky enough and we're going to be able to register and record this thing.
Definitely. I think we need some decentralized internet nodes as well, you know.
Yeah, well, you think, but that's the really core of decentralization. Mesh networks, the possibility to create this worldwide network of nodes or points that communicate, and we're gonna get rid of the ASPs, and that will be the big day. But
okay, but good to see some good new background. Very lovely room.
Thank you.
Awesome. So today, Rob, we are going to discuss a very important topic: consensus mechanism. I got to see few people have commented, and few people want to know more about DecBC proprietary consensus mechanism. It's proprietary, means it's being invented by us and it's available for the people to reutilize as well, which is proof of participation. So we will build up this discussion and make people understand more about proof of participation. Okay, so Rob, very first thing, I strike to the point. If you can explain the basic difference between proof of work, proof of participation, and proof of stake to our audience, please.
All right. So the consensus system, first of all, is important to understand, is that mechanics, that set of algorithms, the logic that make sure or attempt to make sure that the blockchain cannot be gamed on, so that the blocks are attached one to the other, and nobody can rewrite, reorganize the transaction in the blocks, removing, so that only what people really wanted is recorded in the blockchain. If a consensus mechanics is weak, there are systems for which people can rewrite, so force the node or play or game the node into choosing an alternative chunk of blockchain instead of the one that has been created by the users. This is done to do the classic double spending or many other things. So the logic to do this are very different. There are many. There are several aspects in the consensus mechanics. There are who can create the new block. So first of all, what's the logic on which transactions are included in a block? Because in a peer-to-peer network, no node knows what the other node know. For example, somebody broadcasts a transaction, you may have reached some nodes, may have not reached others. So the mempool, which is let's say the queue for transaction to enter the blocks in the future, is called mempool, may be different block by block. So the account that is assigning, or the node that is signing, depends on the proof of on the consensus system. The new block has the freedom to choose what transaction to include in the block, because others are not there to be able to judge if those transactions were broadcasted or not, or because they have no absolute truth. This is the key aspect of the fact why people can rewrite a piece of blockchain, because people can propose a blockchain, and only what the consensus mechanics consider good is the way that the block are connected to, but they can now validate. Obviously, if a transaction is invalid, and per se, I send you 1,000 Bitcoin when I don't even have one in my balance, that's a block with a transaction that is not valid, and all the accounts on the blockchain, all the nodes in the blockchain are going to reject a block that is not valid. But a block that is valid is going to consider okay, and if the logic on which blocks are connected is good and strong, then this is going to be accepted. Bitcoin, which is the first cryptos which introduced the first mechanics of blockchain, use what is called proof of work. And the proof of work of Bitcoin base the quality of the chaining of block by the result, the fact that someone found the result that is more difficult to find than somebody else. That's really, I didn't say very well, but the logic is this: taking a block and the data in this block, there are some trial and error, adding a little bit of more information in the block until a specific hash, which is a mathematical result from the full content of the block, is produced with a specific logic. So, for example, there is the fact that there's to start with many zeros. How this is done and why is better or no better is very opinable, and there are a lot of supporters of one or the other. But if we're looking at the difference and we let people judge, there are many other aspects and logic that determine what can be done, how things can be handled in the moment that somebody finds the blocks. For example, in Bitcoin, which is proof of work, the result that is more difficult to be found, which means it's an hash that starts with many zeros based on what is required, also gives a new coin base, meaning the new coin created each block, all to the account that found this result. So for a public blockchain like Bitcoin, where the economy is not created at day zero like in most proof-of-stake blockchain, the new coins are given in total for the block to the account that has found the most valid block. And if somebody, so this means that the nodes that are there choose the block that has the better result, which is called higher difficulty because it's the most difficult to be found. In a chunk of blocks, if let's say there are 5-7 blocks proposed as the last 7 blocks, the sum of the difficulty of each chain, this attached block to block, created the total difficulty of this chunk of blocks, and in front of 2 different chunks wins the one with the better difficulty, even if the transactions are different inside this block compared to the one that were already present in the node. Mm-hmm. And anybody can overnight buy enough hardware to participate in the race to find those results. Don't need to have a balance of Bitcoin whatsoever. Can put these things there at work and start mining Bitcoin, which many consider this to be a good thing because there is no censorship or resistance towards the people that don't participate to the club the day before and wants to participate the day after. Nobody can stop them from doing it. Proof of stake, on the other hand, don't require a lot of mathematical calculation, but limits the group of accounts that can propose a new block to a certain subset that is a subset of accounts that have the highest balance and a few other set of things. For example, is long time they don't create a block, so they give them a higher score, and so on and so forth. In this way, if somebody wants to start creating blocks for a proof-of-stake blockchain, he has to buy the stake. He has to have enough balance. And if nobody wants to sell them the crypto, then they are cut off, let's say. And this is the argument of the supporter of proof of work. They say that the things that makes proof of work, Bitcoin open, really open to everybody, and proof of stake not, because you need to be accepted by somebody selling you crypto. On the other hand, people say, well, if they don't sell your crypto, they make the price going up, blah, blah, blah. It really depends. There is also one aspect. When I look at consensus mechanics, I look at those that use external inputs for the security of the blockchain, like proof of work, use hardware device that do this mining, etc., etc. Those that use internal resources, for example, the history of the past transaction in a blockchain to determine who can create the block and how, right? So with these two aspects, the options that are there in the market tend to be staying on one of two sides, right? The arguments against proof of stake is the fact that besides being able to create blocks, you need to have stake. Is the fact most proof of stake have a pre-distributed balance, because you couldn't start with balance 0 in system that require balance to mine blocks, because then nobody will be able to mine blocks. So you need to have a pre-distributed amount, which makes it more centralized. And I do agree.
So in this large scheme of things, where proof of participation would fit in?
I'm flying circles around this territory because I want to land in the perfect place. There are many arguments that push a situation like creating a new mechanics like proof of stakes, right? So the fact that the blockchains are adopted for non-financial use cases, so they are now going to create value in terms of coins, but value in terms of a service, removes a lot of the aspect that makes secure things like proof of work. So let's say there is a consortium of hospitals or a franchise of hotels that need to manage some information between each other without electing a central party that is managing a big database. Why they should run miners and consume a lot of electricity to run their network, it doesn't make any sense, right? And in case they're using a proof of stake, what they're gonna do about this stake? They're gonna balance, then some more new hospital join the consortium, each of them has to send the stake. Doesn't make sense, right? But if you remove the value of the cryptocurrency, the security of the system collapses, because in a proof of work term, let's say there is a consortium of hospitals that run a minimum hashing power just to maintain the blockchain stable. You're gonna have somebody that want to remove compromising information to just put a little bit of miners and rewrite the last chunk of the blockchain of the hospitals per se. Or if it's the proof of stake that manages something, the value, for example, we manage real estate ownership, where a title in the blockchain goes way above the value of the cryptocurrency, then an attack of my purchasing cryptocurrency or in order to rewrite a piece of blockchain start making sense, because all of this. So is it a proof of capacity where I just buy more hard drives? It is really, there was the need of something whose security is really attached to the desire to make the thing secure. So are there nodes participating to the network? Yes. If the node participate, the system is secure. More nodes participate, more nodes are in the hand of different people, more the system is secure, independently of the fact that the system is running a cryptocurrency or not. And the security comes from a cryptographic history of keys. I apologize, I have a baby in the room that cries.
No, perfectly fine. This just shows that even Roberto has to handle a family.
Anyways, so the idea is that there is the need of a system that maintains security based only on nodes of the network being there, independently of crypto or not. So Proof of participation is something that come out by the need of making a system where a peer-to-peer network can stay safe, create a blockchain safely, independently by a financial value, by the value of a cryptocurrency. So it should stay there safe by the participation of the node. So the biggest challenge has been the one to measure the participation of the node, because you can't ask an opinion to one node about what the other node do, because they can lie and they can come together to kick out another node. So the difficult thing was how do you measure the participation of a node in the blockchain without allowing anybody to lie, and actually making in such a way that if somebody is trying to manage another node by not making it work, not making it do his job, he get damaged himself. So the mechanics was boiling down to all the peer-to-peer communication that are there in a peer-to-peer network for the blockchain. Rather than just broadcasting information like this, any information that is broadcast is digitally signed by the broadcaster, and the recipient is going to send a signed receipt that they received the broadcast. So it takes a little bit more traffic in doing this aspect. It's not done with all the things, but with the key things. And we don't want to bloat the blockchain with a lot of useless information. So this data is kept in the node itself. The node builds a Merkle root of this information. A Merkle root is hashes of hashes. So I take two pieces, I make their hash, and then I make the hash of the two hashes, so on and so forth. So I can create a pyramid with 50 pieces of information, but I come out with a single hash. And these hashes are published in the blockchain. And when an account is called on a specific transaction, it can bring proof from the transaction up to the Merkle root that he participated in that specific transaction. Furthermore, very opposite of what Bitcoin does, Bitcoin rewards the account that created the new block. But what we do is to reward everybody, so distribute the Coinbase to everybody in the case of a blockchain with the cryptocurrency, and punish that don't create the block when they're supposed to do so. So it's reverse, right? There is a pseudo-random system that elect 10 nodes, 10 accounts, let's say, to as the one that should create the block, the block at the new pools, right? And they have no previous warning. They cannot calculate when it's going to happen to them, so they cannot keep a node offline to go online only when they're requested to be there. So if or pretend with a fake application, they pretend to be a node without being a node, for example. So in the moment that they produce the block, they are rewarded with participation score. If they miss the block, there is the account after them that has the right to make the block, and so on and so forth. So all of them prepare their own blocks, but only the top one that is presented is the one that is selected. The blockchain, if there are two alternative blockchains, the blockchain with the highest difficulty, so the one that the consensus mechanics, just to arrive to the point of the consensus, chooses, is the one where the top accounts are the one that created the block. So there are no skipped smitters, as we call them. So in this way, you have a measurement of the participation of the accounts in the blockchain. You have a way to create the blockchain perfectly like every other blockchain, but you have no value. So there is no way to purchase power in this game.
Absolutely, absolutely. And I think this is the one thing that makes proof of participation a completely decentralized consensus mechanism, because you just cannot buy power with the help of money. You need to be there. I have a few questions, interesting ones for you. Number one, can it happen like I will bring lot of nodes along with me, I join proof of participation network and I start hijacking the network? Like I bring 100 nodes with me and suddenly, that I have hijacked the system because I have more nodes which I can control as an individual.
All right, that's a good point. And the logic of the consensus for proof of participation does not allow this. So it's not like in proof of work that somebody can go out and rent hashing power and in a minute become the most powerful account to produce blocks. But in proof of participation, with our logic, new accounts can be added to those groups that can create new blocks have a very slow pace. So bigger is the full network, faster new account can be added. And smaller is the full network, slower account. Let's say with 200 nodes present in the network, one new account can join every 36 hours. With 1,000 nodes every 8 hours, and so forth. So this forces the person that want to perform the attack to go very long in the plan of the attack. And as soon as there are only two people trying to attack, they eliminate each other. As soon as other people want to add nodes to participate in the blockchain, they are killing the attacker at the same time.
Okay. My another question to you, Rob, how the rules for calculating the participation score, is this something that the network will decide and make it public? Or it is like before I would become a part of the network, it would be like completely transparent for me? And once the network started, can network decide that they need to add more rules, they need to take out a few rules which are calculating the participation score? How this thing of calculating the participation score is being maintained in this decentralized setup?
Well, everything that is decentralized, the code is transparent, so there is no secret how they work. The code is also open source, so the rules are in the code, right? So there is no... Obviously, with time can become better and better as soon as we understand this issue, bugs, etc., etc. There have been some issue with the collection of receipts. There are a lot of small aspects that need to be coded properly. But sure enough, it is okay as it is now, yes, and it's been proven to be okay. Okay. And one very important question, because everybody is talking about this Bitcoin, the energy is used for it. It's not green. It is using a lot of non-renewable sources of energy. It takes a lot of hashing power. Proof of stake is the way to go. And here we are coming with proof of participation. How green we are from a proof of participation perspective. Sure, proof of stake and proof of participation are not high consumption of energy, but they are so small that it can run in like a Raspberry Pi in small computer. So small solar panel and you can power your node day and night and run in a small device. So the problem with the proof of work, and I do believe it wasn't thought about that by the initial developers, is the fact that the greed of people in getting these new Bitcoins push them to bring the difficulty so high that only few huge warehouses full of computers that there are able to produce some results, removing all the other people from the capacity, the possibility to participate. He actually gives it a bad name because people that don't understand blockchain don't understand there are many things that any blockchain has the problem that Bitcoin has, which is not the case. Thank God.
Awesome. And from a proof of participation perspective, so how easy it would be for someone to start getting the rewards by becoming a part of the network, like you have mentioned, and you have absolutely put it very correctly, that in proof of work you have to buy more hardware in order to get that reward. It happens that you might, because somebody else has invented the block or figured it out the block before you actually can put it in front of the network. But just by becoming a network, would I just start getting the rewards in proof of participation? Even I'm not defining the block, but I'm just helping out to send the communication, propagation of messages with all those things, because every participation has a score.
Yeah, sure, but practically to be part of the network, there is a waiting list. Let's say once the blockchain is running, exactly because only one new account every several hours can be accepted. All the accounts that are in queue to enter, they need to wait. So it's not instant to be part of the network. Once node is in it, then automatically start receiving rewards, but also it's going to be request to create the blocks. So once one start the game is in the game. A way to not to have to wait in the waiting list is to have a node, so an account registered in the Genesis block. Genesis block is the block 0 of the blockchain, with an account in the Genesis block. Then at the day 0, at the moment 0, the node is running, is immediately already collecting rewards. Okay.
And tell me one very interesting thing. What motivates you to come up with proof of participation? What actually triggered you that I need to come up with some consensus mechanism that would have this property 1, 2, 3, 4, and how long it would take you to actually come up with this concept?
Well, the interesting thing is this. The adoption of a blockchain for non-financial use cases. That's what push the need for something that is safe independently. Or for things of value, the value much more than the economy of the blockchain. Let's say warehouse receipt, where one receipt can represent $1 billion worth of metal left at the port, etc., etc. If the blockchain has a market cap of $2 million, but handle receipts that are worth $1 billion, then it's easy to go around and purchase a coin. I'm talking about a proof of stake blockchain, right? And to then become in control of, the moving of the blockchain. And also where there is no value whatsoever, for example, medical receipts or diploma, documentation flow, etc., there must be no way to interfere with the blockchain. So surely people that run the node care for the service provided, but it doesn't have to be money. So it has to be people do protect things that they care for, right? So if they care, they participate. It doesn't matter they have supercomputer or little computer, doesn't matter. Important that they're there. They are the holder of a different cryptographic key, and all together in the network, they can create a very beautiful and strong cryptographic security for the network.
Okay. Awesome. And in which language you and your team have coded proof of participation, which is available even on GitHub? Is it in Rust, Python, Go? In which language is it being coded?
But a perfect system has a good protocol, and this protocol should be working in application made in many different languages, right? So let's say the protocol To give an example, is the file.docx that is a Microsoft Word file. But if it can be read by 10 different applications, there is not just Microsoft Word with the same source code, then you have a very secure system, because if one of those has a bug and suddenly it's not available anymore, you still can read the document with something else. For a blockchain, nodes should be implemented in many different ways, respecting 100% the protocol. So that's the key of the security, is the design of the protocol. Then to create the first node is the most complicated things, because there are a lot of issues and finding small bugs and realizing that there are things to straighten up, etc., etc. And we use Golang, because it's simple and the availability of developers that can code in C are not as big as the one that can code in Golang. It's easy to learn. In fact, many developers arrived to work in the project that didn't know Golang and learn Golang in a very short time. But that's just for having an easy way to code and prototype the first system. But the goal is to have many different implementation with the perfect support to the protocol. That's the goal.
Okay, awesome. I think today we have discussed about this consensus mechanism a lot in detail, and thanks for explaining about proof of work, proof of stake, and proof of participation. I think this would certainly help our audience to understand where proof of participation would stand, why it is so different, and how it has more utility, or how blockchain would become more usable for non-financial use cases as well from the business perspective. So good to know about this. And audience, if you really want to read more about this in detail, please do see the link of the book which is mentioned in the description of this video. It is free available. You can download it in the form of a PDF. And I will also share the link if somebody wants to buy it from. Here we go. Yeah, Roberto.
It's a beautiful full color book with a lot of illustrations and a lot of QR code to interact. Very nice.
Yeah, awesome. And if somebody is in UAE wants this book, please mention to me. I will give it to you. Okay. Thank you, Rob. Thanks a lot. Enjoy your vacation. Thanks for taking out time for me to record my 5th episode. I'm very grateful of you, and hope to see you soon in action. And enjoy this break with your family.
Thank you. Bye, Jaspal.
Thank you. Bye, Rob. Bye.